Okay, so for today, we're not just expanding logs, we are also changing bases on a log. And let me explain about that just right off the bat. Would you agree that this log, even though it doesn't have a base, has a base of 10? Okay, so what if I didn't want it to be base 10? What if I wanted it to be base 5? It seems like it'd be really complicated, but it's really not too bad. So if it is base 10, it's super easy to enter on the calculator because you get that on your calculator you have a button called log. And that assumes you're using base 10. So there's some calculators that can only do logs in base 10. So how the heck would you put in log base 3 of 11? You have to have a way to somehow change them to be base 10. So we have to be able to change the bases. So how do you do it? Here, it's this simple. You say, I want this to be a different base. Like, it could have started as anything. Let's say I started it as log base 4 of 5. I want the base to be different than 4. Well, start with this. Everybody please copy this one down. You need one good example of changing base. This is going to be log 5 over log 4. I want you to just process that for a second. If you typed the left one in, log base 4 of 5, you'd get a certain decimal. And I know that decimal's just a little bit more than 1. You know why I know that? Because if I made this into 4 to the power of 1.1 or 1.2, 4 to the power of 1 point something would give you 5. And then the answer is the power. So I can tell you that this is a little bit more than log base 4 of 4, so it's a little more than 1. All right, so what exactly is it? Well, you'd probably need to type that on your calculator because most calculators don't have a way of directly typing in base 4. Some do. If you have the new spanky like software, their latest update, if you have the newer kind of calculator, it'll go like this, log base box of box. And then you can just put in whatever base and argument you want. That's really cool. Texas Instruments did that a few years back, but not all of you have that. So you can't count on that. But this you can count on. And it shows you that you can change it to base 10. But wait, Mr. Server, what if I didn't want base 10? What if I wanted like base 7? The weird part is that you can make it any base you want, and it'll still say the same. Now let me make sure you understand why. If I had 20 over 10, would you agree that's equal to 2? What if I had 40 over 20? Would you agree that's still equal to 2? Do you get if both numbers go up proportionally, 20 turned into 40, 10 turned into 20, it still gives you the same answer. So if I take these bases that right now are base 10, and I know that to me is already hard to believe that is exactly equal to that both sides are equal, but it's true. And they have base 10 right now, but I can make it any base I want. So if my problem was make this into base 2, I can just put a base 2. And I just scaled down both numbers. Actually, I scaled up the answers. The answer to this is a little bigger because I made the base smaller. The answer to this is a little bigger, proportionally bigger, so they stayed the same. So the answer is just log base 2 of 5 over log base 2 of 4, and that both uses log base 2. All right, I know I may have lost some of you there. Let's just do one more simple one. Log base 3 of 11. Right now, do you agree it's base 3? I can make it any base I want, but start by making them both base 10. Dominic, is that your phone? Oh, good. Then log base 11 over log base 3. That's all there was to it. And just subtly, now, it's a different base. What base is it now?
110.
Base 10. It's also called the common log, because the most common log is base 10. But I didn't want base 10. I wanted base 1.3. Well, then you can just put in any base you want. And if it was base 10 a second ago, now it's base 1.3. And I scaled up both answers proportionally, so the final answer is still the same as this. So the answer still comes out the same as that. But it can be any base I want, like base 1.3. One reminder, a ton of kids last hour had forgotten this. Do you get that the one base that's not allowed is base 1? Did you know that? Base 1 doesn't exist. So that's the one number you couldn't change this to. Of course, I think you remember that the bases have to be positive. But even if you use positive 1, it won't work. I'm going to remind you over here, because I just said you can change the base to anything. I want to be clear. You can't change it to a 1. Why can't the base be 1? Let me show you. Because if I say this equals n, I don't know what it equals. Then 1 to the n equals 2. And then try putting a power here that makes it equal to 2. Usually you can, but not in the case of 1. 1 is the only number where when you put it to any power, the answer stays 1. 1 to the negative 1, still 1. 1 to the 0.5, still 1. Third root of 1, still 1. You can make any power you want and it won't ever be 2. So you can't use 1 as a base. Do you get if we put this on the test, it's a trick question? Doesn't exist. You could say that. It doesn't exist. There's no base 1. Okay. So here's a typical set of questions for today. Go to page 1, expand and simplify. Oh my gosh, that looks impossible. It's not. Trust me, this isn't as bad as it looks. It is not even close to as bad as it looks. We just have to break it up into more than one log. I think I've tried to tell you, and I think you know, that whenever you see a log base that doesn't have a base, you put base 10. So do that. And I've also said, take math one step at a time. There, I made it a little better. Now what could I do next? Focus on this. Do you get that down deep, that is two things multiplied? Then it can be split into two logs. The part I just circled in red, make it into two logs. Log base 10 of something, and another log base 10 of something. And this being multiplied here means we're adding between them. And then this part just goes here. And this part goes here. Now there's more to do. We're not done, but I have broken it into two logs. It is more expanded than it was. Now I got to do this divided by. Do you guys remember what that means? Minus. And another log. What is the base on that one? Same base as the other one. Base 10. And then I put this 7x minus 2 here. Now that doesn't have parentheses, but early in the year I told you that if there are no parentheses around things in a fraction, there are implied parentheses. Put them in. I know. It's like, well, why didn't you put them in? Because you don't have to, because they're implied. Sort of like saying, hey, I'm having a party on Friday. Your implied is you're invited to the party. Otherwise, I wouldn't have told you about it. I wouldn't tell you about the party and then say, and you can't come. You see, it's implied. You can come to the party. So if they put 7x minus 2 here that didn't have a parenthesis in the first place, there's a parenthesis there. So why does it matter? Because if it's inside, then that's different than if it was outside. See, if I erase these parentheses, then all of a sudden it's log base 10 of 7x. And the minus 2 is like moving the whole thing down. It's different. So you need those parentheses right there. Okay, so there. I've expanded it. You happy? No, because there's more work. Graydon, you've been gone, but were you able to watch the video to know where to put this 3? All right, do that. That 3 goes here. This 2 goes there. And that one doesn't have a power. Well, that means it has a 1. Well, I could put a 1 there, but there's already a 1 there, right? So we don't really need to put the implied 1 in there. Now, is that good enough? So here's how you ask yourself that question. Can I break up this any further? No. I know it's tempting. You might feel like you can make that into 2 logs. You can't. When there's add or subtract in there, in the argument part, you don't break it up anymore. This cannot be broken up into 2 logs. No. If they were multiplied, sure. If they were divided, sure. But not add or subtract. And this cannot be broken up anymore. So then I know I'm done. That's how you can know you've expanded it as far as you can. All right, so let me give you one that a ton of kids forget to expand it all the way. Write this down. Log, no base, which means you know the base, 4y. It seems so simple. Expand and simplify are what the directions always say. And expand implies expand it all the way. And simplify implies simplify it all the way. If you got an answer after 1 second, you better double check it. Did you expand it all the way? All right, check with the kid next to you and see if you caught it and they didn't. Lux, you gotta give Hudson somebody to compare with. See, if you just broke it up into log 4 and log y, you didn't expand it all the way. Why not? Because I said, look here. Can you break that 4 into something times something? Yes, you can. You can break it into 2 times 2. So that means you aren't expanded all the way. So I make this 4 into a 2 times 2, but I do it with a power. 2 squared. That means 2 times 2, doesn't it? And then the power can move to the front, and that is considered expanded all the way. Because see the argument? It's a prime number. Can't break it up. See this argument? Can't break it up. Except you do y times 1, and that's not going to really make it any simpler. This one looks like it's going to simplify down further because it feels like it should just turn into 1, but it doesn't because the base is really a 10. So it's smart to put in your base when you don't have a base so you aren't tempted to by accident simplify that down more. And you can't. You can't make this 2 into a 10. There's a decimal for it, but I wouldn't expect you to be able to do that. 2 is 10 to the what? I don't know. Okay. Let's move on to another one that gets people on the test. You ready? I haven't even looked at the test. I just remember from past years, we always put things like this on there. And there's a, sure, I get it. There's a minus because there's a divide. Yeah, but do you really get it? Write down what you think the final expanded answer is for this. The first part's easy, but are you going to remember all the little stuff? Because math rewards careful people. So, did you break it up into 2 logs with a minus? Well, that's a good start. And I know you're like, well, I know, move the 3 to the front. Okay, good. Most kids remember that. But, and even some kids are going to be, oh, so you mean we should make this into 10 squared and move the 2 to the front? Kind of. Would you agree that I said to put in the base when there isn't a base? Then, do you notice that these 2 are the same? So the whole answer to this whole thing is just 2. Did you put a 2 there? Raise your hand if you had a 2 there. Okay, it's about half the class. Minus 3 log base 10 of x. The way you could know you're not done is because if I move this 2 to the front, 10 can be broken up further. So the fact that it has a base 10 is the key on this one. Since it has a base 10 and it's of 10, then that whole thing is 1. 2 times 1, 2. Could have just grabbed the power of 2 right there and put it right there. So then I said, always check this part. Can you break up the x anymore? No. So then it's expanded all the way. Do you get the trick on that one? All right. Here's the last kind. 3 ln e over 16x. Expand that all the way. You know, that's too cruel. We're going to take the 3 off the front. It's going to make it just too complicated. We wouldn't do that to you on the test, so I'm going to put the 3 here. Because technically, if I put the 3 in the front, it would affect the denominator too, and I don't want to do that. It would be too complicated. All math can be done, but, you know, at some point it's honors level, and we're in regular, so we're not going to mess with that. One step at a time. Amy, what did I say about ln? You turn it into log base e is correct. So that way you've got a base. Next, the whole point is expand. So it's 2 logs, log base e and log base e. And it might even be more later when we expand it again. This first part, that goes here. And this part goes here. And because this was a divide, I put a minus in between. I'm not done, but that's correctly started. Now, some of you sharp cookies have already changed this into a 3, and that was smart. 3 minus log base e of 16x. Now the question is, are you going to handle this negative right? Are you going to do it correctly? I feel like I should break this into 2 logs because there's a times in here. And it's true. I do want to break it into 2 logs. And I should put a 16 here and an x there. But I'm conflicted on whether or not I should make it minus or positive. What do you think the right answer is? Should this be a positive in here because we added them together? Or should it be a minus because there's a minus out in front? And it feels like it should distribute. You got to be on team it's a plus or you're on team it's a minus because of this negative here. Decide. What do you think it is? Talk to the kid next to you. Do you think it's plus or minus? I'll pause while you debate it. So this part turned into 3. This part feels wrong that it's a minus there, but it's because this is a minus and it's like there's a parenthesis there, and you're going to distribute the minus to both parts. Okay. Go on to this slide. The only thing tricky here is that y square root, there's going to be a few kids that don't know what to do with the square root. But I think most of you will know, oh yeah, that means to the power of 1/2. Not all of you, but most of you would know that. This one's going to be pretty impressive. Base 10. Break the whole top up and you'll have a whole big bunch of logs. And then you go minus, and then you have a whole another big bunch of logs. Go ahead and do that one. Pause for a minute. This is the only really hard problem today that I need you to try your way through. The only really hard one. Okay, this top part would break into 2 logs. Log base 10 of this part, x to the 3rd. And then this is a times in between these two, so that means plus. Log base 10 of y to the 1/2. Now, if you want to get fancy and do this all in one step because you see it coming, go ahead. Take the 1/2, put it here. I'm just trying to do it step by step for you. And I look here and go, can I break it up anymore? Nope. Can I break it up anymore? Nope. then this part has a divide, so I do a minus. And remember those implied parentheses around that? Log base 10, because they're all base 10. And then z to the third, t to the fifth. Now, I got to break that one up. Oh, tons of kids leave this on the test. I remember grading these over and over again, and tons of kids will leave it just like that. Because they feel like I already did it, but you haven't broken this up yet. So, I'm going to leave this part of my answer alone. That part was fine. But this turns into minus, and it's like there's a parentheses. So I'm going to distribute the negative to both parts. That negative will go on both things. So this will be 2 logs again. Log base 10 of z to the third and minus, remember I'm distributing the negative, log base 10 of t to the fifth. And if you get so fast that you just write the 5 here right off the bat, I'm good with that. And this 3 right in front, I'm good with that. There we go. Now how do I know I'm done? Look at the arguments. X and Y can't break up. Z can't break up. And T can't break up. Cool. And be careful with that negative. All right. I told you there'd only be like one really hard problem. That was it. This is just reminding people about how to change bases. I told you this. Log 16 over log 3. And what base would it have then? Base 10. That's called the common log. But you quickly realized you could scale that to anything you want. You could scale it to a 5 if you want. It could be log base 5. Because that just, by making the base smaller than 10, I'm making the answers bigger. That got a little bigger, and that got proportionally bigger, so the answer stays the same, no matter what base you use. All right. And then this is just a reminder that there is such a thing as condense. You condense it to log base 6 of 15, and since there's a minus there, it would be divided by 3. And the kid writes that, and I mark it wrong, because why? What's wrong with that answer? It was right so far. Nobody knows? What's wrong with that? Because let's look at the directions. They don't even have the directions. It says, this is the part that is not said, but I'm going to say, the directions are always condense and simplify. Is 15 divided by 3 really simplified all the way? What is 15 divided by 3? It's 5. That should be a 5. And then it's log base 6 of 5. And then do you remember me saying that a lot of calculators can't put that in? So then we have to do the base change thing. Log 5 over log 6, and it could be any base, but the one the calculator does is this one. Just log, which is base 10, but you don't have to write the 10. That is in the common log, which is the calculator's way of doing it. So that's the same exact thing as that. How'd I do it? I condensed it first. I simplified it, which nobody saw coming. Then I wrote it where the base wasn't 6 anymore, the base was 10. All right, this is the part where you get to go to your homework. Everybody find the homework. It's just the answers. I'd like you to start it with me. Number 2. Turf, could you read me number 2?
Log base 10 of 1,000 x to the power of 3, y to the 4th.
Okay. Well, I feel like the directions are probably expand and simplify. Is that right?
Yeah.
Okay, well, one more thing. I think it says something about put it in the calculator. Don't. You don't have to put anything in the calculator because you won't have a calculator on your test. So then, log base 10 of 1,000. Later I'll make it better. Plus log base 10 of x to the third. I'll fix the power of 3 later. Plus log base 10 of y to the 4th. And now you look back at your arguments and go, could I make that any simpler? Yes, I can. Oh, it's 100, not 1,000? Okay, thank you. It's all right. No big deal. There. Okay, and now If you just make this 10 squared, you're missing the big picture. Now the bases are the same, so this whole thing is 2. Can I break this up anymore? Yeah, because of the power of 3, so move it to the front. Now can I break it up anymore? No, so then you must be done. Can I break this up anymore? Yeah, it's y times y times y times y, so you could put the 4 in the front. That is problem 2. That was an expand. I'll do what I preached. Look at the arguments. Can I break them up anymore? Nope. Always check that. That's what'll get you on the test, is if you didn't expand it all the way. Or simplify it. Like this simplified to 2. So easy to forget to simplify it all the way down to a whole number if you can. All right, that's all I got for you for today.